A particle is moving in a straight line with a velocity given by, we've got this nice little formula here, v of t is t cubed e to the t to the 4. It doesn't look like we have units, but this is as a function of t minutes from the start of observing this particle. Okay? So, math question, we don't really care too much about units unless you start mixing units. But if you want, you could assume maybe the velocity here is meters per minute or something like that. I don't know. At least it doesn't say right now. Let's finish reading the question. Okay? Determine the net change in the particle's position. So this is another term for that would be the displacement of the particle between 2 minutes and 5 minutes. Okay. So displacement or net change in position is found by integrating the derivative of position, which is velocity. Well, we've got the formula for velocity. We want to go from 2 to 5, so this shouldn't be that bad. So I said displacement. I'll stick with the net change words just to match with the question, but we'll say net change in position. So we just set up. You're going to integrate velocity from 2 to 5. So that was t cubed e t to the 4. And it's a definite integral. All we got to do is find an antiderivative, plug in 2 and 5, and we'll be all set. When we look at this, well, this is kind of complicated. Off the top of my head, I don't know what an antiderivative for this is. But I might notice, hey, we've got e to the t to the 4. There's a composition. So maybe we could try a substitution. Okay. U to the t to the 4, du by dt, 4t cubed. So rearranging this a little bit, the dt that we want to replace is du over 4t cubed. Now remember, when you're doing a substitution, you do have to change your bounds as well. So 2 to the power 4, well, you probably know that one off the top of your head. 2 to the 4 is 16. 5 to the power 4, well, I know that one off the top of my head, but that, I do a lot of math. So 5 to the power 4, what's the new upper bound going to be exactly? Well, we could work it out. 5 times 5 is 25. All right. 5 times 25, so 25, then carry the 1, so you get 125. Okay, and then 5 times that, so 25, carry the 2 there. Oh, sorry, this was a 2. 5 times 2, so 2, carry the 1, and then 625, which is correct. Okay. All while, somebody at home is still fumbling for their calculator. No, there we go. So 16 to 625, great. We got t cubed, but then this turns into a u, so e to the u. Alternatively, by the way, you don't have to change the bounds. If you ignore the bounds, get an antiderivative, and then switch it back in terms of t. That's also a perfectly valid strategy. But dt is du over 4t cubed. So the t cubes go away. We can bring out the 1 over 4. And what are we left with? Integrating e to the u, which is super easy. So we'll have e to the u. And we'll have 625 and 16 and plug them in. So e to the 625 minus e to the 16. And all multiplied by a quarter, or we could say all divided by 4. And that, in whatever units the question is, if it was meters per minute that the velocity was, then in this case we will have gone this many, the particle will have gone this many meters. Right? But math question, we're not so concerned with units unless we're having to mix and convert between them. So there we go. The number is all that matters to us right now.